Welcome to The Explainer. Today we're diving into one of the most useful tools in any programmer's toolkit, the adapter design pattern. Now this is a really simple concept, but it has some seriously powerful applications.
So let's just jump right in with a problem that I'm pretty sure we've all run into. You know that feeling, right? You've got two things that should work together, but their connections, their plugs, they just don't line up. It's that classic, frustrating problem of incompatibility.
In the real world, maybe it's your phone charger when you're traveling in a different country. And in the software world, well, it happens all the time. Maybe your app churns out data in XML, but you've got this shiny new analytics tool that only speaks JSON. The core job is the same, but the interface, the way they connect, is totally different.
And the solution for both of these problems is actually super simple and elegant. You use an adapter, right? Instead of tossing your charger or rewriting that entire analytics tool, you just put a little something in the middle that lets them talk to each other. So, let's put a formal name to this solution. This is the adapter design pattern. It's what we call a structural pattern, which is just a fancy way of saying it's all about how you organize and structure your classes and objects to build something bigger and more flexible.
Its main job, its whole reason for being, is exactly what we've been talking about. It lets different classes work together even when they weren't designed to. It's all about creating teamwork between parts of a system that would otherwise be speaking completely different languages.
You know, thinking of it as a bridge is probably the perfect way to get it. A good bridge doesn't change the land on either side, does it? It just creates a path between them. And that is exactly what this pattern does inside your code.
And once you start looking, you see these analogies everywhere. It's the power plug adapter for sure. It's the memory card reader that lets your tiny SD card plug into a big USB port. It's even like a language translator, allowing two people to have a full conversation without either one having to learn a new language. They're all adapters. Okay, so how does this magic trick actually work in the code? Well, the pattern really comes down to three main characters working together in this little play. So let's meet them.
All right, let's break down the rules. First up, you have the target. This is the interface your main application, your client, is expecting to see. In our example, that's the analytics tool that's waiting for some nice JSON data. Then you've got the adaptee. This is the object you have, but it's got the wrong plug, the wrong interface. That's our class that's giving us XML data. And finally, the star of the show, the adapter. This is the translator, the bridge, the class that makes the other two play nice together. And the way they all interact? It's beautifully simple, really. Your client code just talks to the adapter, thinking it's the real deal, the target it was designed for. The adapter takes that request, does a quick translation under the hood for the adaptee, and then passes the result back. The real key here is that the client is just happily chugging along, totally clueless that this whole translation is happening behind the scenes. And that's the whole point.
Okay, so theory is great, but let's see how this plays out in a real business. When the food delivery app Swiggy wanted to start delivering groceries, they ran smack into a classic adapter problem.
See, their whole system, their entire world, was built around food items. Every single item in their database had a name, a price, and a restaurant name. But a grocery item? Well, that comes from a store, not a restaurant. The objects were almost identical, but that one little field, store name, made them totally incompatible.
So what did they do? Did they rewrite their entire system? No way! They just built an adapter. This little piece of code would wrap around a grocery item, and whenever the old system asked for a restaurant name, the adapter would cleverly hand over the store name instead. Now, this wasn't just a neat coding trip. This was a huge strategic win. It let them pivot their entire business into a brand new market without having to re-engineer everything from scratch.
So you might be thinking, okay, this sounds like a bit of extra work, right? Creating this whole new middleman class. So what's the real payoff? Why is this pattern so popular?
Well, the benefits are massive, and they go way beyond just writing clean code. For a company like Swiggy, this means business agility. It's the power to reuse perfectly good older systems. It's the freedom to react to the market and add completely new features without getting bogged down by old decisions.
But, we have to give a balanced picture. It's not always a perfect solution. No design pattern is a silver bullet, and you got to know the potential trade-offs with the adapter pattern too.
The main thing to keep in mind is that you are adding another piece to the puzzle, another layer of code, and that can make the whole system a little more complex to understand. And for applications where every millisecond counts, that extra translation step can add a tiny, tiny bit of performance overhead. It's usually not a big deal, but it's something to be aware of.
All right, we've covered a lot. So if you only remember one thing from all of this, what should it be? Let's boil it all down to the single most important idea.
The adapter is your secret weapon for making things play nice together without having to tear them apart and change their original code. It's the ultimate bridge builder, giving you flexibility and the power to reuse by connecting what you have to what you need.
And that's really the adapter pattern in a nutshell. It's a powerful, elegant solution to a super common problem. And now that you know its secret, I bet you're going to start seeing it everywhere. Where do you think it's hiding?